Hey everyone, welcome back to this Python series. My name is Ansh Patania, and today we are going to start our most important topic of Python, which is object-oriented programming. So without wasting any time, let's get started.
In languages like C++ or Java, you have strict keywords like public, private, and protected. Python takes a different philosophy driven approach we are all consenting adults here. However, Python in languages like C++ or Java, you have strict keywords like public, private, and protected. Python takes a different philosophy driven approach called we are all consenting adults here. However, Python provides a convention to make attributes and methods private by prefixing their names with a double underscore. Let's understand how it works. With an example. First, we are defining a class, bank account, constructor, def init, self, comma, account, holder, comma, balance, password. Self dot account holder is equals to account holder self dot balance is equals to balance self dot password is equals to password. We can add branch here. Which will be predefined self default value self dot branch is equals to downtown. So let me tell you, this is public. Account holder is a public attribute. This is a protected attribute. It's also called convention. This is a private attribute, balance, and this is also a private attribute. Now we have to make a public method to access private data safely. So let's create a function called display balance self my user pass if user pass is equals to self dot password. Print account balance for self dot account holder as self dot balance else print invalid password access denied. Now we have to test our access account. Account 1 is equals to bank account. Current comma 5,000. Let's say 50,000 comma secret 1 2 3. This is our testing access. Now we have to make a public attribute. So, for example, our holder name, comma account 1 dot account holder. Now we have to make a accessing private attribute directly. Fields try print account 1 dot password. Accept attribute error as E. Print error code comma E. Now accessing public methods in which we account display balance. It will display our balance. So account 1 dot display balance secret 1 2 3 account 1 display balance. Wrong pass. So let's run the code. There is an error of attribute error on line. There is an error attribute error bank account object has no attribute. Line number 9. If user pass is equals to self dot password. Wait guys, let me check what is the error. Class bank account def init. If user pass is equals to self dot password, self dot password is equals to password. Still getting it wrong.
self dot password. Oh, my bad. So we have to add the public and private properties. Now it will work. Now, as you can see, it is working. So let's break down our code line by line. So first we have created a class here, a bank account, and after that we have defined a constructor in which there is account holder, balance and password, and we have a default value of branch which is downtown. So here self dot account holder is equals to account holder. It is a public attribute I told you earlier, and self dot branch is equal to downtown with a single underscore. It signals to developers that this variable is intended for internal use only. Through though Python doesn't enforce it strictly, and here self dot password with double underscore. It is a prefixing. It is prefixing with a double underscore marks these attributes are private, and after that we have defined a display balance. And now let me tell you the try from line number 19. So try print account 1 dot password, which is attempting to read account 1 password, directly raise an attribute error, bank account object has no attribute password. So now account 1 dot display balance, here account 1 dot display balance, it provides a controlled better interface that verifies the information before revealing internal data. Now, how does Python actually hide private variables under the hood? Python does not create true hardware level private memory blocks. Instead, it performs naming mangling. When Python sees password inside a class named bank account, it automatically rename it internally to underscore bank account double underscore password. Let's understand how mangling works, and let's understand this with an example. Here we are going to learn a new thing, which is a property method, @property. So print mangling access comma account 1 dot bank account password. Class student def, we are making a constructor here, init def init self comma marks self dot marks is equals to marks. Now property method @property def marks self comma marks self. This is a getter method which returns self dot marks. This is a private info because we have added two underscores.
Now at the rate marks dot setter at the rate marks dot setter def marks self comma value. This is the setter method with validation. If 0 is less than or equals to value and value is less than or equals to 100, self dot marks, which is a private info, marks is equals to value. If 0 is less than or equals to value and if value is less than equals to 100, the marks will be equals to value. Else print invalid marks. Now S is equals to students student 85 print student marks comma S dot marks. It reads like an attribute. S dot marks is equals to 105. S dot marks is equals to 95. It will be rejected by the setter validation here, this 105, and this will be successfully updated 95. So let's print the final value, final output. Print is equals to, not print is equals to, print updated marks comma S dot marks. Let's run the code. There is a name error, account 1. Where is account 1? This is of this is from our old code. The last example. This one. Now let's understand this. First, we have created a class student, and then we have created a constructor. Defined a constructor self comma marks. Self dot marks is equals to marks. And we have, let's start with print account 1. Let's start from property. Now what is this property method? It turns def marks self into a read only getter attribute. You can access it as s dot marks without parentheses. And at the rate marks dot setter defines a setter method that automatically fires when someone attempts S dot marks is equals to value. This enables input validation, for example, rejecting marks outside 0 to 100. It will reject all the values which will be less than 0 or greater than 100. Now moving on to our next section, section 2, the del keyword and memory management. Del keyword, this one. So when building large applications that run on cloud servers or handles high user traffic, managing RAM memory becomes essential. Python features an automated garbage collector, but you can explicitly delete attribute or entire object using the del keyword. So let's understand this through in code, your code. First we will define a class. Class user session def init self comma username comma if token stake token self dot username is equals to username self dot token is equals to token def display self printf session active self dot username. Now instanting the session user user1 is equals to user session Rahul Dev. XYZ token user1 dot display and now we are going to use delete del method, deleting a specific attribute. So let's delete the token del dot user1 dot token. Try print token comma user one dot token except attribute error as a print attribute detected attribute deleted comma e. Now we are going to delete the entire object. Delete user1. Try user1 dot display accept name error as print entire object removed from array, comma e. Let's run the code. There is a syntax error again. User session. What is the syntax error? Class user session. Oh. User session. It will run. Again, there is a syntax error. Tell.user. There will be no route. So let's break down the code here. First, we have created a user session, and after that, we have created a constructor self comma username comma token. And let's start from the del function. Let's start from line number 12. Del user1 dot token. It removes the token attributes specifically from user1. The object user1 still exists, but accessing token throws an attribute error. Now moving on to line 19th. Del user1. It unbinds the variable reference user1 and our accept name error as e, since the reference user1 no longer exists in the local scope. Calling user1.display raise a name error. Now, how does Python's garbage collector knows when to delete an object? Python tracks the reference count, how many variables point to an object. When the reference count drops to 0, Python calls the dunder destructor method del and reclaims the memory block.